lesson 2-3, please remember to put your name on your paper and the date and the period. We will be looking at parallel lines and triangle angle sums. Our objectives today are: we will use lines constructed parallel to another line, to solve problems and prove theorems. We will also use the sum of the angle measures in a triangle to solve problems. Your essential understanding for today: the sum of the measures of the interior angles of a triangle is 180 degrees, and the measure of an exterior angle of a triangle is equal to the sum of the measures of their remote interior angles. So at the end of the lesson, you should go back and check that you have the essential understanding. In this section, we will investigate the measures of triangle angles. Oh, there's a typo. Investigate the measures of triangle angles. We have angles 1, 2, and 3 in this triangle, and they are colored red, blue, and green. And if you were to take each one of these pieces of the triangle, like if you were to tear those off and then line them up, they would make this set of angles on a straight line. And it works with any triangle. So right now we're going to pause the video, and you are going to get 3 triangles. You're going to color each side or each angle a different color and label them 1, 2, and 3. And then you're going to glue them in your notes. Over here. So you'll have angle pieces like this, and you'll have them be in different colors. All right, so now you're going to get your 3 triangles, and you're going to have them pasted into your notes like this. So you'll have 3 different sets. And they'll all be numbered. Like so. So that's what we're going to do. In this section, we have a couple theorems. Theorem 2-10, and the number doesn't really matter, says that through a point not on a line, so a point not on a line, there is one and only one line parallel to the given line. So what that looks like is if we have the point P right here, and we have the line B, then we can draw another line, and that line would be A. It would be going through point P. Okay? And there's only one parallel line to line B that would also go through the point B, meaning we can't draw another line that's parallel if it goes through P. The second theorem that we have is theorem 2-11, the triangle angle sum theorem. And what that says is that the sum of the measures of all the angles of a triangle is 180 degrees. And you'll get to practice that this week, but if we add up 55, 81, and 45, they will add up to 180 degrees. You should already know that though. Let's look at some proofs. In this proof, it asks us to prove the triangle angle sum theorem. So we're going to prove that when we add up all 3 angles of a triangle, it is equal to 180 degrees. All right, we'll start out with step 1. Through a point not on a line, there is one and only one line parallel to the given line. That's the theorem that we just learned on the last page, on the front of these notes. To the given line. So from that theorem, we are going to draw a line through C and parallel to AB. Can you hear my dogs playing with a squeaking toy? All right, so we'll draw a line that is parallel to AB right here. All right. Step 2. By the angle addition postulate, the measure of angle 4 plus, I'm going to put that on the second line just because. By the angle addition postulate, the measure of angle 4, which we'll put up here along with 5, plus the measure of angle 3, plus the measure of angle 5 is equal to 180 degrees. Do you see that? Because it's a straight line. So if we add up 4, 3, and 5, it's 180 degrees. Step 3. We're running out of space, but I'm going to just come up here to the top. Step 3. By the alternate interior angles theorem, angle 1 is congruent to angle 4, and angle 2 is congruent to angle 5. We can see that. I'll grab the highlighter. So we have angles 1 and angle 4, and angles 2 and 5. So this is congruent to this. And then I'll choose a different color for 5 and 2. Because they are alternate interior angles. They're cut by this transversal, those two parallel lines, and then the other one is cut by this transversal. And then because of that, we can write a conclusion that angles 1 and angle 2 and angle 3 equal 180 degrees. And that's by substitution. Because what we can do, let me finish writing this by substitution, because we can say from, let me grab the highlighter, angle 1 is congruent to angle 4, and angle 2, right, is congruent to angle 5, because we just said that up here. I should unhighlight that, but I can't, to make them yellow. There. And by we can just substitute those in, and we can see that the green, angles 1 and 4, can just be substituted in for each other. so that we can show that angle 1, 2, and 3, which are the angles inside the triangle, add up to 180 degrees, proving the triangle angle sum theorem. All right, so we had step 1, step 2, step 3, and a conclusion. We have another example.